Hello, this is Tolbert's class. This is Physical Science, Tolbert's class. This is Chapter 14. This here is lesson number 4. How atoms of various elements are different. So, here's where we start talking about it's the same element, but it'll have different numbers of neutrons. These are called isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. The mass number of the isotope tells you the number of the protons plus the numbers of the neutrons. Notice the picture on the left-hand side. You have carbon 12, carbon 13, and carbon 14. So, it's named that because carbon always is going to have 6 protons. It's called carbon 12 because in this particular one, the protons plus the neutrons will give you 12. And the next one, in order to be carbon, it's got to have at least 6 protons. And this one here is going to have 7 neutrons. That combination gives you 13. In the next one here, the 6 protons plus 8 will give you, so 6, 7, 8, 9, 10, 11, 12, 13, 14. That gives you carbon 14. That's how you find those. So almost all elements have more than one isotopes that are stable. Stable means the nucleus stays together. If it's not stable, it becomes what we call radioactive. Isotopic symbol, you're going to need to write this. You're going to need to know how these look. Okay, so the X, A, Z, and the N. The X is the element symbol. Ooh, let's back that up, 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 back that up. Let's go previous. All right, so let's get it going here. Element symbol. It's the X to the A to the Z. Element symbol is the X. The A is the mass number. The Z is the atomic number. Remember, atomic number is the number of protons. So it's the X to the A to the Z. So if we write carbon here, this 12 is representative of the mass. So that's the protons plus the neutrons. This 6 is just the protons, it's the atomic number. Let's get more specific about radiation. Isotopes. Isotopes may have unstable nuclei. They spontaneously or naturally emit things to become more stable. They are what we call radioactive. Elements greater than the atomic number 84 are all radioactive. Radioactivity is a process by which an unstable nucleus emits one or more particles of energy in the form of what we call electromagnetic radiation. Charged particles being emitted or given out from an unstable nucleus. In other words, charged particles being kicked out by an unstable nucleus. I kind of think of this as you teenagers, once you get too old staying at home, your parents want to kick you out. So, because you make the home unit a little unstable, because you want to come home and you want to come home and do all the things and stay partying and not work. So some of the parents might want to kick you out of the house. The house is the nucleus, the parents kicking you out. You are the particles being emitted. Writing isotopes. So here's the isotopic symbol, and we've just talked about this, where you have the atomic mass number, which is the sum of the protons and the neutrons, the atomic number, which is just the protons. There it is. Using your periodic table, you'll be able to find this. So the first thing you do, of course, ladies and gentlemen, is look up 58. 58 will give you your element. 58 is the number of protons in the nucleus. 41 is the protons plus 141 is the neutrons plus the protons. Here's how you predict what's going to be formed in radiation. The formula down below is what we call a chemical formula. In this chemical formula, it gives you what you start with and what you end with. First, you write down the equation with the original elements on the left-hand side and the products on the right. Use the letter X. Remember, it's X to the A to the Z to show these are unknowns, and we're going to be filling in these knowns. Next, write the math equation for the atomic and the mass numbers. So 117 equals A plus 4, 89 equals Z plus 2. You can rearrange these equations, or 117 minus 4 is going to give you A, and 89 minus 2 is going to give you Z. This is going to give us a brand new element, element 87, francium, because we reduced the atomic number by 2. There it is, francium. So, if you're trying to predict what's coming out, here's my given. I have AC. Over here. This here is given, and this is also given. So what do I need to do? In order to end up with helium on this side, I'm going to be subtracting 4 from that top number and subtracting 2 from the bottom number. So subtracted 4 from 117 gives you 213. Subtracted 2 from 89 gives you 87. Types of radiation. You have alpha, beta, and gamma rays. Alpha particles are particles of helium. Beta radiation is kind of magical. This is where a neutron becomes a proton and emits an electron. And gamma radiation is just pure energy. Alpha particle, identical to the helium nucleus. 2 protons and 2 neutrons being kicked out of the nucleus. Beta particle is magic. It's kind of Harry Potter-ish. Here's where a neutron switches up, becomes a proton, and emits an electron. It's magic. Gamma is just pure energy. So the mass number stays the same. There isn't any more or less protons and neutrons here. Mass number stays the same, just energy. All right, this is the end for lesson 4.